Our final speaker of the night, and just to give you an overview, one of the first, this conference, MagnoliaJS is one of the first, no, not one of, the first conference that I emceed pre-pandemic, and I met a lot of people, but I met 3 people, and I want you to imagine this. I met Gant Laborde, who I already knew. I met Ken Wheeler. Yeah, okay, if you know. And I met Mr. Nader Dabit. Now here's the deal. All 3 of them are super smart, right? Gant is smart, but he's 11, right? Ken is smart, but he's a multiple felon, all right? Nader is smart and honestly one of the nicest people you will ever meet. This guy is so incredibly humble, and I was kind of amazed by that because usually, I don't know if you've met programmers, you guys have a problem with humility. But this young man is incredibly humble. He is so giving. And one of the things that I emceed an event way up in Grenada, Mississippi. It was a movie, not a video or a movie thing that they did for the people there. It was really wonderful. This young man was one of the sponsors of that. So whatever smart stuff he's going to talk about, and he's going to talk about some really high-level smart stuff, right? He's even a better person. So, number 1, buy his books. How many we got? 2, buy his books. Number 2, if he's speaking somewhere, make sure you get there, right? And 3, I still want to figure out, why are all you programmers so jacked up? What is going on? Why y'all, what kind of, y'all like lift or something? Lift everything. I would do it. Oh, so now I'm fat. All right, you know what? I take it back. He ain't nice no more. You've been elevated. Not a chance. All righty. Ladies and gentlemen, please enjoy the intellect of the awesome Mr. Nader Dabit.
All right. Can everyone hear me okay? All right. So first of all, thank you for that introduction. I think he needs a huge raise, whoever is paying him. And yeah. And whenever we're done, just come by and I'll give you the tip. I paid you to say all those good things about me. So also, I wanted to say a huge thank you to Kayla and her husband and all of the other organizers of this event. Mississippi, yeah. We have a lot of talented, really smart people that grow up here and often, either go to school here and earn their talents here, but they often leave because they get offered these great jobs and they end up kind of like having this brain drain. So we need a lot more. We need more culture. We need more events. We need more community things to happen around here. So events like this are extremely important, and I'm really appreciative of them putting all the time and effort. And also Mississippi Coding Academies, who's here doing a great job. Yeah, I love to see all that type of stuff happening here in Mississippi, so thank you all for that. So on to my talk. I'm going to be giving a talk today about blockchains. Is that working? Let me try connecting to my other connection. That work? Okay, cool. All right, so my talk is called Making Blockchains Suck Less. My name is Nader Dabit. I'm a developer, I am an author, and I'm a teacher, and I'm currently working as a developer relations engineer at a protocol called Celestia, which is the first modular blockchain network. I've worked in the past for Amazon. I've worked in the past for School Status here locally. I've been an independent consultant for a few years. I've written a couple books. I've kind of touched on web development, mobile development, cloud computing, and now I'm focused on blockchains and decentralized web infrastructure. And what I'm going to be talking about today are some of the challenges and possible solutions for enabling kind of maybe a new type of application that we can build using these new primitives that are enabled by decentralized infrastructure, mainly in the form of blockchains. So let's first talk about a couple of blockchain use cases. Blockchains are not databases. They're not really meant to replace databases because databases work really well for what they do, but blockchains bring the ability to build different types of applications. So you often think about how technology continues to innovate and new things come out and we have new primitives to do things, but often those new primitives don't replace the things that we had. Instead, they open up new opportunities for us to do things. So we had the mobile platform came out. We still have mobile websites, but now we have also mobile apps. We had AI and machine learning come around. They did disrupt certain industries, but they didn't replace like everything that came before it. So the way I look at blockchains and decentralized web infrastructures is that they enable new things, but they don't really replace anything that we had before. So a couple of the use cases are typically around financial applications and also public open APIs and data. So financial accessibility. So anyone in the world, any of the 1.7 billion unbanked people can actually just go open a web browser, download a wallet, and immediately start receiving payments in the form often of stable currencies like US dollar, in the form of like USDC. They can't be stopped by the government. They can't be stopped by the religion of their country that might not allow them to open a bank account if they have a penis, which is kind of like what actually is the law in a lot of countries. Not a lot of countries, but in a few countries still. But essentially, there is no middle person that can stop someone from doing this. So anyone can have accessibility to financial infrastructure, and it's also a lot simpler than all of the layers of complexity from your bank account to the bank account of the person in Palestine that you would like to send money to. There is no middle person. It just allows them to transact permissionlessly, I guess you could say. The interesting things to me beyond finance, though, as a developer, are more around back-end infrastructure. So when we think about building applications, we typically build our backends and our databases from scratch. We can't really rely on anyone else's data and use it, right? So if I'm going to build an application, I'm not going to say, oh, I'm going to go build this next $1 million company on top of Facebook's API or Twitter's API. Now, you could do that, but when you go to sleep at night, you're not going to wake up. You're not going to go to sleep at night knowing that that API hasn't changed. In fact, Twitter used to have millions of dollars of businesses built on top of their API, and then they decided to change it one day. And then all those companies either had to shut down or figure out something else. But with blockchains and immutable backend infrastructure that are enabled by blockchains, we have this new primitive that is a completely open and public database that anyone in the world can access. And it's also backend infrastructure that anyone can build on. So if I build a social network on a blockchain, then anyone else that wants to utilize that backend can just build a new front end. So now we have the composability that we used to only have in open source code and open source software. We're now having open source backend infrastructure and open source data. We also have additional primitives and characteristics that might be interesting to certain people, but maybe not people here in Mississippi, but things like censorship resistance, which might be important in places like the Middle East during Arab Spring, or China, or maybe even in the Ukraine, where they're currently using blockchain infrastructure to store archival data from the war. And then you have this idea, and it currently is something that's starting to become a reality, is more robust infrastructure, because you don't have a single point of failure. You typically have your applications running on a decentralized network of nodes, meaning 99% of the network can go down and your application is still up. A good example of this is Ethereum. Even though Ethereum is very expensive to use and probably not the best use case, but this is kind of where we're headed, I think, as we see improvements to these types of networks. But we still have a long way to go, and that's kind of what I want to talk about today. What are the challenges for blockchain adoption? Why aren't these ideas things that we start using every day? Well, we're starting to see them. You know, Instagram picked up some stuff, Reddit. I'll talk about, you know, Starbucks, all these other companies that are adopting. But they're only starting to do that now due to the innovation that we've kind of seen. So some of the challenges are around scalability, accessibility, and user experience. And I'm going to kind of dive into a little bit of each of these really quickly. So let's talk about scalability first. I worked at AWS, where Michael Liendo, who's currently here on the same team he was on, for a little over 3 years. Scalability is almost a solved problem at this point. You can literally go to AWS, spin up a database like DynamoDB, and you can use the same infrastructure that Amazon uses that powers applications that alone can handle 100 million operations per second. And that's pretty crazy that we can do that. And this is like, it's obviously not a solved problem. Like no normal developer can just go build a company, an application that scales to this way within a couple of days. They might have to spend some time getting there, but the actual infrastructure is there. Whereas in the blockchain world, these primitives don't exist yet. They exist, but they don't scale, I guess you could say. So with DynamoDB, 100 million operations per second, we instead have people in the blockchain world who are essentially going on Twitter and sending out tweets that they're excited to hit 4,000 transactions per second. Now, this isn't on a single database that's only used for a single application. This is a shared execution. You're now kind of like thinking, oh, okay, so if you have 10,000 applications, each one of those with 10,000 users, you start realizing that this is not a long-term solution. So we need more scalability. The next challenge is my microphone not working? Or is it, can you hear me still? Okay, I'm just gonna talk really loud. The next challenge is accessibility. So it's simple to talk about accessibility in blockchains because it costs money to actually do anything other than read data. So if you want to actually send a transaction on anything, you actually need money and you need to pay that money. Whereas in a typical app like on Twitter, if I like a tweet, I'm not expected to have to pay money to like a tweet. That's crazy. If I'm on Facebook, I'm not expected to pay money to post something. That's not something that is feasible for adoption around the world, especially beyond the United States and Europe, where we might have maybe the money to fuck around and do stuff like that. But let's say 90% of the world isn't gonna like buy into that. The last thing is mainly around wallet and security, and it has to do with user experience beyond the things I've already talked about. So wallet is your identity. It's a bad name for it, but it's essentially a way to have a identifier that uniquely identifies who you are. You can use this to sign into applications. You can use it to do all types of stuff. But you can also use it to accept payment. So it's kind of like the name of the name of it is a wallet, even though I don't think that's the best name. A bad user experience that is kind of part of most blockchain applications is that you actually have to sign a transaction every time you send any type of update to the database or to the blockchain. Meaning that if you wanted to like a tweet, you like the tweet and then a pop-up comes up and you have to press a button. You post something, you press send, then another pop-up. So that's not a good user experience. And then finally, security vulnerabilities are very unforgiving, meaning that if you get tricked on, like, let's say your American Express, you can call and they'll refund that money probably. If you get tricked on your application with your wallet and you lose $100,000, you literally are never gonna see that money again. It's never ever coming back. And that's not good for people that make these mistakes as they're learning. So those are all areas that we need to solve. And there's probably been hundreds of billions of dollars that have gone into this space in the last year or so. And while there are people that are building applications using the current infrastructure, a lot of the teams are actually focused on solving a lot of these challenges. So I'm going to talk about some of the solutions and some of the solutions that I'm currently working on with my team at Celestia, as well as some other ones that are out there. So virtual machine improvements, this is like vertical scalability. This is kind of like saying we're going to take the server and we're going to make it faster and we're going to make it better and we're going to kind of have improvements done to improve vertical scalability. We're going to work for innovation and experimentation with data storage. So one of the most expensive things about blockchains is storing data on the blockchain, because when we think about storing data in a database, it's very cheap. We can store, I forgot the price. Like, I'm going to keep talking about DynamoDB because it's one of my favorite databases, but it's really cheap. It's like literally almost nothing. But let's say you wanted to store an image or a video on the blockchain, it's actually kind of crazy expensive. So there are a lot of innovations that are happening that kind of realize that we might need some compromise to what decentralization actually means to enable better user experiences by reducing costs and stuff like that. we have this idea of relayers and gasless transactions. So this is kind of like a new idea and a new innovation that's starting to be implemented that I'm going to show you an example of in just a moment. But what this basically means is because we are starting to see newer blockchains that are very, very inexpensive, we're talking about like a fraction of a cent per transaction, then now it makes sense for the platform to subsidize these transactions, meaning that I don't need to pay money to do this. The application I'm using will pay the money for these transactions, and they're setting up a centralized data or a centralized server in between the user and the blockchain called a relayer. And you're now talking to this relayer, which is like a centralized application that then sends the transaction to the chain on your behalf, and you're no longer actually interacting kind of directly with the blockchain. And I talked about how every time you need to interact, you have to sign a transaction. Well, we've now started to see some innovation and some ideas around how we might solve that. One of them is a dispatcher. And a dispatcher is, again, kind of like this centralized, I would say, API that sets aside, okay, we're going to set aside enough gas for you to have like 100 or 1,000 operations on this low-cost network. Maybe that costs a total of 10 cents. And then you can now interact like you would with any other application, and it feels just like you're now using something like Twitter. And then we're now starting to focus on horizontal scalability as well as vertical scalability. One of the biggest good points that people have when they criticize blockchains is that everyone's sharing the same execution environment. Ethereum is a single, it's like everyone going into AWS and sharing one server and everyone in the whole world building on that one server. No one would do that, right? Everyone goes and spins up their own machine, or they might use serverless and have their own infrastructure that they can spin up and spin down on demand. And then there's a lot of investment in wallet UX. So I'm going to touch on 3 of these points in just a moment. And I forgot I added these little things, so I'm going to move past that. So one good example of how we're starting to see a lot better user experience solving some of these challenges is a new protocol that was released from Arbitrum called Arbitrum Nova that kind of combines a lot of the things that I talked about around improved user experience and also decreasing the cost of transactions and enabling, I would say, off-chain data as opposed to having everything on-chain. So Arbitrum Nova uses something known as a data availability committee to store their data. So instead of like all this data being stored on the chain, they've gotten like 10 groups. You could almost think of them as like groups of people that are just running traditional centralized databases that have some type of on-chain agreement to keep the data lively and up to date. And then now, whenever someone needs to like read the data, they're not having to go directly to the chain. They're now kind of reading it from this data availability committee, and they're posting attestations of the updates to that data on chain. So you have like these updates that are stored on chain, but the data itself is kind of stored off chain. It's using something called a sequencer, which is, you could think of it as like a centralized program to batch and compress transactions before being sent to the base chain, which then gets sent to another chain. But yeah, it's kind of going into the weeds here, but it's like this point of centralization where in the past everything was kind of like hyper decentralized. We're now having these like points of centralization that are kind of serving to provide a better user experience without compromising on the security, I guess you could say. And then the cost of this chain is very, very inexpensive. It's like 1/10 of a cent or so per transaction, meaning that people criticize Ethereum, rightly so. It costs $1 or 25 cents or whatever to do stuff there. But when we're talking about 1/10 of a cent, this is the type of cost that could be subsidized by the applications themselves. And a good example of that is Reddit. So Reddit is the first team to adopt Arbitrum Nova, and they're using it for their community points. So why the hell would they use it for their community points? Why wouldn't they just use a database? Well, the cool thing about blockchains is that, again, what did I talk about earlier? They're composable, they're open, and they're public. So what they're now trying to do is open up their infrastructure for community points for other developers to build on. So this is now a composable API layer for everyone to build on. So you can now not only build out experiences on top of their community points for consumption, you can actually build out applications on top of their community points for like actually interactions. So you can build applications on top of their infrastructure that they're implementing for community points. And then there's another protocol that's similar to Arbitrum Nova called Polygon, and it's been picked up by Instagram, and Starbucks, I think yesterday or a few days ago, announced that they're doing some of their point system there as well. Another good example is Lens Protocol. So Lens Protocol is a composable and decentralized social graph. A social graph is basically the type of application that all of us use on a day-to-day basis. So it's almost like every social media application that exists. YouTube, TikTok, Facebook, Twitter, Instagram. These are all social graphs. They all allow you to create a profile, follow people, post information, and view a feed of content. So this design pattern is like everywhere. So Lens Protocol wrote this design pattern into a smart contract and deployed it open source, and then also deployed it to Polygon. So you can either fork it, deploy it yourself, or you can use the Polygon implementation of this. Things that they've done a little bit differently is that they build a GraphQL API on top of it that is a centralized API that is something like a sequencer with a relay and a dispatcher, meaning that you can interact with this API with GraphQL and you don't have to know anything about blockchain. You can also interact directly with the protocol on-chain, so you have both options. They have enabled this idea of a dispatcher, which I talked about earlier. You just click a button, you sign it. You're now just interacting with all of these. You're interacting like you normally would on Twitter or something. No more signing transactions. It's free to use, so you don't have to pay for any transactions, which is great. And they so far have signed up 50,000 people, and it's still in beta, so you can't really just like sign up. You have to get on a wait list, but it's becoming, it's pretty popular and stuff like that. And then the thing that I'm personally working on is modular blockchains. So modular blockchains are attempting to solve the blockchain scalability trilemma by decoupling all of the mechanisms, the core functions of a blockchain. So a modular blockchain is any blockchain that or I would say outsources at least one component of a chain. So what are those four components? You have execution, settlement, consensus, and data availability. Celestia is the team that I work with, and our blockchain focuses on consensus and data availability. So on the left is kind of like the traditional blockchain. It's essentially monolithic, meaning it does everything. Modularism is kind of like how we're starting to see microservices be adopted in like the cloud world. With microservices, each layer of the stack can do one thing, and it can do it really well, and you can kind of focus on that thing that it does, and you're not really bound by any of the bottlenecks maybe of the other pieces of the system. So what are some of the benefits of this and as it applies to blockchains? So the one that excites me probably the most, I guess, is scalability. When we think about scalability in the traditional tech stack, all we're really thinking about is kind of like how many transactions or operations per second can this system handle without having any negative effects on the system itself. But when we think about blockchains, like what's the difference between a blockchain and a database? Well, a blockchain is essentially now also taking into consideration the transactions per second or the operations per second divided by the cost of the average user to verify the data in that actual network. So that data verifiability is really the only thing that separates the two. Because if you had a blockchain with no one verifying it, then you have basically just a database, right? So how does that verification happen? Well, it happens using typically what is referred to as a blockchain node. And when you think about Bitcoin, which was kind of the original blockchain, you had the ability, and you still have the ability to essentially verify that chain pretty easily. And you can download the node on your computer actually and verify it. But as blockchains have scaled, we're no longer just handling basic financial transactions. We're now handling, we have blockchains, like I mentioned, that are starting to handle thousands and tens of thousands of transactions per second. So with all of those transactions, you have a lot of data that's stored. So when you're wanting to store this data and verify all of this data, the computing power necessary to make that happen is actually going to be too much for most people to run on their machine. So what ends up happening is you now are increasing the resource requirements for people to run these full nodes, and therefore you're then again decreasing decentralization, because now you only have a few people around the world who can actually afford to run this infrastructure. So a good example of this is like the Solana blockchain, Solana blockchain is just a blockchain, but for you to actually run a node in Solana, you have to actually have a few $1,000s, and also if you want to participate in the network to verify transactions, you need even more money than that. So that actually is not a good thing. We don't want that. We want anyone to be able to participate and help verify the chain, and therefore we now have also seen this idea of light nodes starting to become part of most blockchains, I would say. But the problem with light nodes is that with full nodes, you're downloading and verifying the entire chain. Light nodes are only downloading the block headers, and the block headers have metadata that kind of tell you what the information is underlying that network, but it doesn't actually give you all of the same security guarantees of a full node. So therefore, if you have a blockchain that is starting to have a lot of resource requirements to verify everything, and a light node isn't giving the same security guarantees, you're kind of stuck. You don't really have a good solution for that. So what does Celestia do? Well, we provide a solution for two things, but one of them is trying to solve that challenge that I mentioned earlier around having light nodes able to verify the network with the same security guarantees as a full node. And we do that using a technique called data availability sampling. And this gives light clients a over 99% security guarantee that the entire block is valid by only downloading less than 1% of the block. So it's done using a technique called erasure coding. And erasure coding isn't like anything new. It's basically what's been used for a long time. So what you might, if you've been around back when we used to have CDs and DVDs and stuff, like if you scratched your DVD and you put it in, it would often still work. So how did that actually work? Well, the information stored on that disk has erasure coding applied to it, which basically means that it's copied the data that is there multiple times and put it in different places. So once you start reading the data, if it's not in one place, you can kind of read it from another place. So without going into too much complexity about how this actually works, because it is kind of nuanced, using this technique, we're able to, with minimal back and forth on the network, have the same security guarantees as a full node by having this data availability sampling that's implemented using erasure coding. So what this does is it reduces the cost for average people to operate nodes on the network and verify the network, but it also enables us to scale the block size almost infinitely, whereas that was a huge limit for most blockchains in the past. So as the block gets bigger, we add more nodes to the network, we're able to kind of continue to verify and keep not only the security of the network the same, but we're also able to keep the applications on there running with the same performance. So yeah, to kind of like wrap up that part, this means that increasing the block size and network throughput can be securely achieved by increasing the number of nodes that make sampling requests for block samples, for block shares. And then the last thing that we focus on is around decoupling consensus from execution. So again, this is kind of like this idea of vertical scalability versus horizontal scalability. So when we think about most blockchains, again, we're talking about a shared execution environment. This means that with Ethereum or Solana or any of these blockchains, when I launch an application and Michael launches an application and then someone else launches an application, we're all sharing the same server you could think of. Now, that's not a good thing, because if my application starts becoming widely used, then there's now a bottleneck on everyone else's application. That doesn't make a lot of sense. So how can we get beyond that? Well, there's a reason why that exists. It's because it allows really easy interoperability between the different applications that are running on it. So what we need to do is we need to make it easy for people to build their own blockchain execution environment themselves for their application specifically, and then we need interoperability between those different applications. And we're focused on the former, and we're working with teams that are focused on the latter. But when we think about scaling in the traditional software world, we again have vertical scalability and we have horizontal scalability. Vertical scalability increases the size and the performance of the environment that you're in, and then horizontal scaling just adds typically more instances to that. So often when you're looking at how to actually improve scalability, horizontal is often the better approach once you hit a bottleneck at the execution layer or at the vertical layer. So what essentially modular architectures enable is for people to be able to build their own application-specific blockchains just as easily as they in the past would have deployed their own applications as a smart contract. So instead of us sharing an execution environment, we have our own execution environment that will enable like anyone in our app to use it, but not anyone else outside of our application. In addition to that, this modular architecture enables specialization at each layer. So the Ethereum implementation has something called the Ethereum virtual machine, which is a virtual machine implementation that if you want to use Ethereum, you have to kind of go by. So you don't have any way to say, oh, I don't like this feature, or this is a really big problem for me. But regardless of who built that or how it was built, you have to use it. So each of these main monolithic blockchains that exist today has their own form of a virtual machine, and you don't have any say-so on any of the decisions that were made when they built that. But if we now decouple the execution from the rest of the network, or the rest of the architecture, we can now allow people to experiment and play around and open source different virtual machines, and we can fork each other's and improve each other's and kind of build on the improvements as they go. We're not really stuck to anyone else's decisions. You also have flexibility because, again, if I do want to build my next application using Rust, or I want to build my next one using Solidity or maybe even JavaScript, I can reach for the different pieces that make sense the most for me. I might choose like a Rust-based execution environment to build my application because I have that flexibility. And then it also enables more experimentation because I know that if I can just go fork someone else's execution environment and deploy it, then I might be more likely to try that out and maybe open source my own updates. So that's kind of it for me. For further reading, if you're interested in this stuff, I would check out celestia.org/learn. I would also check out our docs at docs.celestia.org. And I would also check out this podcast interview from Mustafa Al-Bassam, who's our founder. And he has a really interesting story, but he also has a really good interview here called Disruptors, Modular Blockchains for Sovereign Communities with hacktivist Mustafa Al-Bassam. And that's it. Thank you.